Alright, today we're going to talk about our last exponent rule, and that is the power to a power rule. The power to a power rule states that when an exponent is raised to another exponent, you multiply the exponents. So if we look at example 1, we'll start off really basic, n to the second power raised to the third power. This is what I mean when an exponent is raised to another exponent, or a power is raised to another power. So if we want to, we can multiply that, which is n to the 2 times 3, which is n to the 6th power. But it can get confusing when there's more things inside the parentheses. So I think expanding it is the best way. So we have n squared 3 times. So we have n squared times n squared times n squared. N squared 3 times. So this is n squared raised to the 30th power expanded out. Then we can expand this out again. N squared is n times n. N times n, and n squared is n times n. Then we count them up. 1, 2, 3, 4, 5, 6. And we have, again, n to the 6th power. Again, I think expanding it is the best way to do this so you don't confuse your powers because you'll forget to multiply something. Let's get a little bit harder. Example 2. 7v to the 3rd power raised to the 4th power. This is where people will make their mistake. You have to remember that 7 has an exponent of 1. When there's no exponent there, you have an exponent of 1. So we have to multiply 1 times 4 on the 7 and 3 times 4. This is why I think expanding is better, because you won't forget about the 7. So you have 7 to the 4th power, v to the 12th power, and 7 times 7 times 7 times 7 is 2,401 v squared. But if we expand it, we can do 7v to the 3rd power times 7v to the 3rd power times 7v to the 3rd power times 7v to the 3rd power. This is 7v to the 3rd power 4 times. So you write what's in the parentheses 4 times. A lot of people forget to multiply and put the power on the 7 if there's nothing there. That's why I say expanding it is the best way. And again, 7v to the 3rd power is 7 times v times v times v. And we're writing that down 4 times total. And again, 7 times 7 times 7 times 7 is 2,401. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get the same answer. Again, I think expanding is your best option. Alright, now we're going to do an example where we're combining everything else we've done. Example 3. We'll do 2 examples like this. We have 3a to the 0 power, all squared, over a to the 3rd power times 3a to the negative 3rd power. So the first thing that you want to do is you always want to move your negative exponents. But remember, you only move a to the negative 3rd power. The 3 has to stay because that doesn't have a negative exponent. So we're going to move that to the top and then rewrite it. 3a to the 0 power squared, and then we have a squared. Remember, or a cubed. When it comes to the top, it's positive. Then we have a cubed left on the bottom. Now we expand. 3a to the 0 power, 3a to the 0 power. This is 3a to the 0 power twice, so we wrote it down twice. Then we have a to the 3rd power over a to the 3rd power. Now we're going to expand all of our a's out. Remember, anything to the 0 power is 1. So we have 3 times 1 times 3 times 1, a, because a to the 3rd power is 3 a's, over a to the 3rd power, which is a. And again, a divided by a is 1, so we can cancel them out only when they are on the top and the bottom. So that leaves me with 3 times 1 times 3 times 1. 3 times 1 is 3, 3 times 3 is 9, and 9 times 1 is 9. So we get 9 as our final answer here. Oh wait, we forgot about the 3 on the bottom. I didn't bring that over. I apologize. I didn't bring this 3 over on the bottom. So we have to bring that over, and then we do 9 divided by 3, which is 3. Alright, example 4 is our last example. This is a big one. We have 3a squared times 2a to the negative third power to the negative fourth power over 2a squared. So the first thing we want to do is we're moving all of this because it's raised to the negative fourth power. So that's going to come to the bottom. So we have 3a squared over 2a squared times 2a to the negative third power raised to the fourth power. So now we can expand again. We have 3a squared over 2a squared times 2a to the negative third power. And we're going to write that down 4 times because we have 4 2a's to the negative third power. Now we have a to the negative third power. All of these a to the negative third powers are going to come to the top because they're negative exponents. So we rewrite it again. 2a squared, a cubed, a cubed, a cubed, a cubed. All 3 of these a cubes came to the top. Over, that's supposed to be a 3. So we had the 3a squared up top, and we brought all of our a cubes up top. On the bottom, we have 2a squared times 2. 1, 2, 3, 4. We have 2 times 2 times 2 times 2. So now we have 3a, a, a, 1, 2, 1, 2, 3, 1, 2, 3. 3 more a's and 3 more a's over 2 a, and then we have our 4 2's. Now we cross out what's in common. I can't cross out any more a's because I'm out of a's on the bottom. So now we have 3a to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th power over 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. And that is our final answer. So you just need to take it step by step. Rewrite your powers to a power first and move your negative exponents first. Then expand everything else out.